So there are two aspects to windows and doors. One measured in PHPP, which is the heat loss from inside to outside, and then the heat gain, which is the solar gain from the sun. So it's that balance between the gain against the loss. Hence the orientation of the building is very important, about which way the windows are facing, how many windows are facing in any one direction. Obviously the sun's mainly in the south of this part of the world, so we have mainly our windows on the south side for obvious reasons. We're using EcoPassive triple glazed windows with a centre pane U value of 0.55. They're inward opening and they have a polyurethane thermal break in the frame, leading to a whole window U value of 0.75. We believe, and looking at the modelling that's been done, that a window halfway within the insulation layer performs best. So what we have is a plywood box, a plywood former, which we build here at the mill, and they will be built in by the masons on site. So that's a four-sided box, screwed and glued with foamed glue, so they're airtight in their own right. The advantage of that is that you have got a formwork for the openings within the masonry, straightforward, no mucking about. You'll see that we are trying to wrap the insulation around the frame as much as possible. Again, that's to stop this movement, this thermal movement from warm to, in the worst situation, cold. Okay? And inward opening windows help us do this, in that obviously the thicker part of the frame's on the outside with an inward opening window. The next one's airtightness. We've got our airtightness layer here, which we've talked about earlier, which is wet plaster. Wet plaster is airtight, as opposed to dot and dab plasterboard, which is generally not, because obviously the dabs behind do not seal the blockwork, which isn't airtight. It could be said that parging the blockwork before dot and dabbing might be airtight, but I feel, from a good constructional point of view, that wet plastering, you're sure of what you've done. But it's always the junctions which are going to be difficult for obvious reasons, because you get differential movement between different materials. So in this case we've got plywood, wet plaster and the window. So we use a ProClimer product, which is a backed tape stuck to the plywood here, and it then has a fleece part to it which is moulded into the wet plaster as the plastering is done. So that stops any air movement between the plywood and the wet plaster. The other weak point will be the window and the plywood, and you use a tape basically which seals that gap between the window and the plywood all the way around. Now I'm going to talk about thermal bypass in the window wall situation, or should I say us cutting out thermal bypass. So here we have a section, a vertical section through the window opening and wall. We don't want any air passing through this insulation in the cavity, because what that does is wick heat from inside the house. But we do need our windows to be in the middle of our cavity. We were therefore left with this detailing, how to close between the window and our outside masonry. This is peculiar to cavity wall construction, and we've come up with a detail that I think is very robust and economic. So we've had aluminium sections made here at our mill, and they've been cut to length on site. They're basically let into a groove into the front of the timber frame, and then it rolls round and is neatly masticed against the stone reveal. We also obviously silicon the joints at each corner. This is the more standard aluminium extension sill at the bottom. You'll see this all over Europe. I'm rather pleased with this detail. Here we have a vertical section of a door opening. Again, we're trying to minimise thermal bridge. We've got to have something more robust for the threshold than we have for the sills of the normal window opening, because we've got people walking over it. We need structural strength, but we also don't want heat almost stored in the ground floor slab, wicking away outside. So we came up with this neat system where we've had made a fiberglass box section, which we chop up in the right length for however wide the opening is going to be. We've then filled that with polyurethane, and we can then rest our aluminium metal threshold on top of it, minimising this thermal bridge. Otherwise we would have had to have brought the slab through to this point, which obviously would have been a terrible cold bridge.